Hello everyone, my name is Mateo Avila, and I am excited to present our work on an efficient and generalizable evolutionary neural architecture search pipeline for image classification. NAS has become a powerful method for automating the design of deep neural networks in different applications, and among the different optimization techniques, evolutionary approaches stand out for their flexibility and their capacity to explore diverse solutions, and it does not require gradient information. But evaluating NAS architecture requires training usually, which makes NAS very resource intensive. And additionally, many NAS methods lack generalizability as they are often tested only on a small set of benchmark data. To address these two challenges, we propose an efficient NAS framework based on evolutionary computation, which reduces available pre-trained weights and uses proxies to reduce redundant computations. And this figure shows our main areas of contribution to evolutionary NAS and the pipeline of our EGNAS based on the modules of the NAS unseen data challenges. So it begins with a data processing module, followed by a search module, and finally by a training module. And we include a low-cost mode that uses a surrogate model to find the best architecture by passing the search. And rather than relying only on commonly used image classification datasets like ImageNet or Cipher, we test our approach on 11 diverse datasets. And these datasets were used in the NAS Unseen Data Challenge 2023 and 24 and provide a robust framework for evaluating the generalizability of NAS methods. So we adopt the RegNet design space, which provides simple and efficient networks and include a high concentration of top performing architectures. And to boost the performance, we also adopted some architectural regularization and training strategies originally proposed for ResNets. To enhance diversity, augmentations can be applied to the datasets, but we don't know in advance which modality or information a given dataset contains, so we propose a method based on zero-cost proxies that consists of computing using only a mini-batch, the normalized sum of Fisher and Jacob covariance as a ranking fit metric that helps filter out poor augmentations from a list of possible augmentations. And we evaluated our EGNAs on an NVIDIA 800 GPU using the 11 image classification datasets and to assess the impact of each component of our framework on the final accuracy and relative score. We defined 7 training modes. Mode T0 is our low-cost mode, and the other modes were evaluated with 3 generations and a population size of 20 individuals. And we compare the relative aggregated scores with scores from different CNN frameworks, networks, and the best score from the 2023 competition, and other scores from NAS methods provided by the NAS Unseen Data Challenge. We also include the mean total time per dataset. However, since no time data was provided for the CNN and NAS solutions, a direct comparison of efficiency is not possible. And our method ranks first in the SADI datasets, achieving a state-of-art score, and compared to the best competition score that requires similar computation time, we outperform them in 4 of 7 datasets. We also show in the paper the results of the other 4 datasets. Okay, thank you for your attention.